Good morning, everyone. So today we're going to answer if all problems using the normalization, database normalization, and also we're going to perform the one to third normal um, form. So for the problem one, we have here the details of patient dental appointment. For this normalization. So as we can see here, we have the original table that includes repeating groups to bring it to one and one end. So we ensure each column contains atomic value and multi-valued attributes. So here's the table you can see. And what I do to achieve two normalization form is we remove partial dependency. We split the data into three tables. So we have here, we split the data into three tables. First is the dentist table. So stores information about the dentist, which is the primary key is the stock number. And for the patient table, we have here, we already separated with three tables. So in this table, we store information about the patient. So the primary key of this is the patient number. So for the third table, all we gotta do is to create a table, and this is for the appointment table. So this table stores appointment information, making staff, patient, and other appointment details. So the primary key of this is the staff number, patient number, appointment date, time. So here is the table. So for the third normalization form, in this case, no transitive dependency remains. So the structure is already in third normalization form. And for the next table, we have here the employee contract. So here, close it down. And as we can see here, the table lists contract, but includes attributes like name and hotel location, okay, and the email and hotel location that is or that are not atomic. So we transform it in already here. And after this, since we have already provided the first normalization form, all we gotta do is to proceed to second normalization form. So to bring this to second normalization form, we separate the data into three tables. So first we have the employee table, which stores the information about the employees with the NIN as the primary key. And for the second table, we create a table for hotel table. So this table stores the hotel details using the hotel number as the primary number. And for the third is the contract table. So the contract table links employee to contract. So contract table uh, stores assignment linking employee, contract, and hotels. So basically, the primary of this is the NIN or contract number. So for the third normalization form, uh, with no transitive dependency, the structure is now in third normalization form. So because there are no transitive dependency left, since all non-key attributes depend on the primary key. So since the second normalization structure above is also the third normalization form. And for the third problem, we have here the student course enrollment. So here, uh, first normal form is already provided. So all we gotta do is to perform only the second normal form, and the third normal form. So to remove partial dependency, um, all we gotta do is to create three tables. So here we created three tables, which is the student table, course table, and enrollment table. So in enrollment table, it contains information dependent solely on SID. So here. So in the student table also, uh, SID is the primary key. And for here, we have the course table. So for the course table, it contains the information dependent solely on CID, which is the primary key. And for the third table, the enrollment table, this links to the student, of course, with grades. So this contains the relation between SID and CID along with grade. So here, we already separated. So here. And for the third normalization form, we separate faculty details into a new faculty table. The structure now adheres to 3NF. So here, the identity and system dependency is the faculty and F underscore phone are dependent on T underscore name. So we should separate them. So we create a faculty table, which is include the faculty and F underscore phone. And we revise the course table, which is or also A3 and F. So for that, uh, we put the CID C underscore name and faculty along with it. So now the tables are in 3NF or third normalization form with all partial and consistent dependency removed. So for the next problem, we have here the um, department employee project. So here, as we can see here, the table lists department, employee, and project with non-atomic value. So each combination of department, employee, and project is separated. So since the first normalization form is provided in the list, so all we gotta do is the second normalization form. So to remove partial dependency, we already created the table to separate it, remove the partial dependency. So here we created four tables, which is department table. I'm sorry, for the is the customer table, product table, order table, and the order details. And for here, um, here is the customer table. So in customer table, um, this uh, this table stores customer information and contains solely the ID. And next is the product table, which is stores the product details solely on the ID as the primary key. And for the order table, contains the relation between OID, O underscore date, and CID. So here, separated here. And for the order table, contains the details of each product in the order. So basically, this is not the department employee project. This is the order table. Sorry for the this. Uh, and for the third table, third normalization for rather, there is no transitive dependency remain, completing the normalization to 3 and F. So the tables are already in 3 and F since there are no transitive dependencies. And for the last table, which is the table 5 or problem 5 rather, is the department employee project. So the table lists department, employee, and project with non-atomic value. So each combination of department, employee, and project is separated. You can put it. And to create the second normalization form, we already have the original table, which is here. And for the second normalization, we decompose to eliminate partial dependency. So to remove the partial dependency, we created four tables. So the four tables is uh, has department table here, employee table, project table, and assignment table. So first we have the department table. So department table stores department information, which is here. And for the employee table, which is the employee table. So contains information dependent solely on IT. So next we have the project table. So this table contains project information dependent solely on the PID, which is the primary key. And last table is the assignment table. So this assignment table links department, employee, and project. This contains the relation between PID, 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 and P time. So here we already separated. You can see here. So moving to 3 and F, there is no consistent dependency. I mean, so this structure is now in third normalization form. So the tables are already in third normalization form since there are no transitive dependence. So we're done answering the database normalization task. Hope you enjoy listening to me and thank you.